Hi everyone. Just a quick update on where we're at regarding saving the files out of the convolution in huygens. We figured out a very simple method to actually conserve the best of both worlds. It consists in saving your deconvolved images as 16-bit TIFF ICS2 files. So when you open a file in Huygens, here this is your undeconvolved image, the original data. You can see that in the statistics tab. So this is your histogram. If you click on statistic, you will see that it is a 16-bit unsigned integer type of file. Okay, so that's usually how you acquire your images. 16-bit TIFF. It's 65,000 gray values range, so it's largely enough. And when you deconvolve it, next to it you have the deconvolved version, it has become a 32-bit float. The truth is, when you save this type of image like this as ICS2, what we were kind of forced to do so far, and save it here and call it, say, 32-bit, it will be quite heavy. It will be a big file. What you can do is, out of deconvolution, your deconvolve file, you go to operations window. You can go also to tools operations window here, and that is also control P. In operations window, you can go to the convert menu and then data and channel type. In data and channel type, you will find usually you will start from 32-bit float because that's the type of data it is, and unless you just like me just used it before, it will revert to what was used the last time. But what you will want to do is go to unsigned integer here in this menu and then push run command, and this will transform your file from 32-bit float into a 16-bit unsigned integer. Here, if you right click this, go save as and save as ICS2, then we'll call it 16-bit. You will see that we have a big difference in size. If I go back to where I saved it, it's in here, there. You can see that my 32-bit is 1 gig and the 16-bit is half of it. So if you open both of them, you will notice that basically there is, well, the difference is that one is 32-bit and the other 16-bit. But when it comes down to the histogram, well, you can't tell the difference because the gray values are the same. So why save this file as 32-bit when in fact you don't really gain in the number of gray values anyway, and it weighs twice it takes twice the space. The real advantage of this, in 16-bit, obviously it takes less space in memory as well when you open it with Imaris, so it works better, it's easier to manipulate, and saving the file as ICS2 will give you the advantage of a very fast saving and a very fast loading compared to saving as TIFF format, but it will also conserve all of your metadata. So you can see that those two files have been opened directly with the correct lookup table. If I go to the edit microscopy parameter, everything is actually in because the metadata is actually perfectly saved and transferred as ICS2 file format, which is not the case if you save as TIFF file. So no reason not to do that in the future. I strongly suggest everybody does that. Transform your output data from 32 to 16-bit unsigned integer and save it as ICS2. It will open perfectly fine in every single software that we know so far, and will conserve all the metadata and will be much easier to transfer, manipulate, copy, etc. Thank you. Bye.